Hey, welcome back. This is Charlie Thompson, and this is a short how to use Google Earth to load a KML file, and also how to do some measuring using the tools in Google Earth. So this is just the address from the lab. If you click it, it sends you here. I don't know why it doesn't just launch, but it doesn't. So we're going to launch it. I'm going to close that tab because we don't need it. I'm also going to go full screen. Okay, and there we've got Earth. Oh, with real-time clouds. Those are clouds pulled in from actual satellite images, so they're current. You can see the ITCZ and the subtropical high, subtropical high. It's funny, the places that have clouds underneath the clouds, the stuff that you can't see is green because it's raining there, right? And then the places that don't have clouds, so you can see the ground, if you can see the ground, it's usually brown because it's not raining there. Because the places on Earth that are really brown are deserty areas. Tropical storm, and the United States. There you go. Good enough. Okay, I would play around, click on the hamburger to open up the menu. If you go to Map Style, that allows you to turn on and turn off labels and borders. I think the default is everything. I'm just going to leave it alone. Close that back out. And I'm going to click on this button, Projects. And it's going to say, make a new project. Well, hopefully you've downloaded the Lab 12 KMZ file. So I'm going to say, open from computer. It says import KML. KML and KMZ files are the same files. KMZ is just a zipped, compressed version. That's super geeky, and you don't need to know it. I'm telling you that because some of you would probably look at this and say, well, it says import KML file. I downloaded a KMZ file. I don't know what to do. Don't worry about it. Just click on import KML file. Find the Lab 12 KMZ file. And when it loads in, it's going to zoom you to the Pacific. It's going to open up, there's a Hawaii folder. There's a San Andreas Fault folder. Inside the San Andreas Fault, there's a Pinnacles Nenach folder and a Carrizo Plain folder. So if you click on one of the folders, it's going to take you to the view for that folder. So the first things we're doing in this lab are playing around with the Hawaiian Islands and the Emperor Seamount chain. Here we've got the Miji Seamount. Here we've got the Kimai Seamount, Abbott Seamount, Midway, Laysan, and then the Hawaiian Islands that are above water, and Loihi. So Loihi, that is the next Hawaiian island. It is still below the ocean, won't be up for about 10,000 years. So this is where the hotspot is. In fact, Loihi is over the hotspot now, so the big island is slowly moving off the hotspot. The islands all get older and older and older as you get away from the hotspot. Kauai about 5.1 million years. Laysan's about 20 million years old. Midway is about 27 years old. Abbott's about 38. Kimai is about 47. And then the Emperor Seamount chain goes up to the Miji Seamount, and that's about 85 million years old. So I'm just using my mouse wheel to scroll in and scroll out. You can click and drag. The Google Earth has some really good tutorials. If you've never used Google Earth before, right now, pretty much all you need to be able to do is zoom in, zoom out, click, and drag. You can also do things like shift click. So if I shift, I can tilt. That's a fun one. I highly recommend that. Control, I don't know what that's doing. Alt shift. So yeah, look through the, that's pretty much, oh, right. So I was going to say, read through the tutorial. There's a couple things that I find super helpful. So down in the corner, there's the little north arrow. So you can, north is not up. North is someplace over here. I've clearly messed this up. But you can either click on the little arrow to restore the north up view. You can also do that. Let's mess it up again. Not having good luck messing it up. You can also hit R. R for restore. Reset. R brings you to, it zeroes out the tilt and it puts north up. So even no matter what you've done, no matter what you've done, if you hit R, it makes everything better. And then to get back, you can just click on the folder and it'll fly you there. Great. Okay, so what have we done so far? We've added the KML file or the KMZ file. We've clicked on the folders. We have clicked and dragged to move things around. So one of the things you're supposed to do is measure the distance between these places. And in the separate how-to video, I'll talk about why we're doing this. But for now, I'm just going to tell you what to do. This is the ruler tool. And you notice when you hit the ruler, it straightens up. So if I try to, let's close that out, shift. So even if I was doing weird stuff before, when you click on the ruler tool, it resets. And now we've got the ruler tool. You've got your options. I'm going to set it to centimeters just because it's going to make the math easier. So I'm going to set that to centimeters. You click once. I'm going to put it over the cursor. I'm going to try to get it as centered on the icon as I can. If I was feeling extra good, extra precise, I would probably zoom in and click. And then zooming in again, click. So the answer, I'm going to tell it I'm done. You can hit enter to finish a line. You can click on done. So that's 32 million centimeters. 32 million 166,000 centimeters. So in the video, we'll use that number, although I'll probably just use the 32.2 million centimeters. Yeah, we could do it in meters, 321,000 meters. We could do it in kilometers, 321 kilometers. Gosh, I love the metric system. I'm just going to leave it in centimeters. And that's how you measure between two places. That actually might be it for this video of how to, is there anything? No, yeah, I think that's it. We've got zoom, we've got loading the file, we've got measuring, and then if I wanted to start a new one, if I wanted to whatever, measure Abbott, and I like to zoom in, you can also click. I'm going to zoom out in the opposite direction because if I was measuring Abbott to Midway, I would zoom in so that I'm actually dead center over the place itself. I've tried to put the icons in places where it looks good if you're zoomed out. So I would zoom in. I'm going to tell it done. And then after you're done, you'll notice the ends are white. So you could actually move and reset. And if you wanted to put it right over the runway at Midway, you could do that. I could zoom out and we'll zoom into the Abbott Seamount. And we'll put it right on that pointy part. So slightly different answer. Good times. So the next thing you'll do is go to the San Andreas Fault. After you're done with that, here's Pinnacles and Nenach. They lie on opposite sides of the San Andreas Fault. 23 million years ago, they were together. And over the last 23 million years, the North American plate and the Pacific plate's been moving to the northwest. The North American plate has been moving to the southeast. And so they have actually been, this volcano has been split in half. And so you're going to measure, click. You're going to measure the distance from Pinnacles. And again, yeah, I would zoom in just to get more accurate. And then the last place is down here on the San Andreas. Oh, I'm clicking on the wrong place. That was Pinnacles. I want to go to the Carrizo Plain, which is west of Bakersfield. And there's these amazing features. So this is the blue line. And if I straighten that out, the blue line is the San Andreas Fault, or at least one of the traces of the San Andreas Fault. It's not like just one continuous straight line. But along the San Andreas Fault, the bottom part here is moving to the northwest on the Pacific plate. The top part is moving to the southeast. And so there's these streams that come down, and instead of flowing straight down, because this plate keeps moving, the streams keep getting shifted. And you can zoom or pan up and down. Like here's two more that clearly are shifting, and you can actually see the fault trace on the ground. Same thing down here. And sometimes you have decapitated streams. So that stream was coming from someplace, but now it's been moved away, and so it's not getting any water anymore. I'm going to go back to, oh, I'm just going to click on the folder, which should fly me there. Good enough. There's Wallace Creek. So you're going to measure from A to B to figure out the rate of movement, and then you're going to measure from A to C to see how old this abandoned channel is. So the river Wallace Creek right now flows like that, but Wallace Creek used to flow, well, it would have looked like that, but this was over here because this entire plate is moving like that. So you're going to do some measuring. That's pretty much it for this lab. While you are at, I didn't want to edit, don't do that. I've included some, view northwest. So the view northwest from Pinnacles is pretty interesting. So now we're looking towards the Bay Area. And I would recommend zooming into the Bay Area and then following the fault up to San Francisco, because there's some really interesting stuff. So now we're on the fault. Right, like these big lakes, these reservoirs. They've put all these reservoirs on the San Andreas Fault, and they're uphill from the cities that they're serving. So Crystal Springs. The San Andreas Fault goes offshore, cruises along for a while. Let me get rid of that. And one of my favorite things is if you've ever been to Point Reyes. Point Reyes is actually on the Pacific Plate. This is the North American plate. And in fact, the blue line is not accurate in this part because this is right in here. So actually, this little bit of Bodega Bay, I think, is on the Pacific Plate. North American plate, Pacific Plate, North American plate, Pacific Plate. So Tamales Bay is actually directly over the San Andreas Fault. And then it keeps going along, keeps going along, keeps going along, keeps going along until it goes offshore right here at the Mendocino Triple Junction, right off of Petrolia in Humboldt. So you can see here an enormous transverse fault. Well, because the San Andreas is, right? So an enormous transverse fault system coming offshore at the Mendocino Triple Junction. In fact, I wasn't going to do this, but here we are. So this is the Pacific Plate. This is the Juan de Fuca Plate, and it is subducting under the North American Plate. This is a spreading center, a divergent plate boundary right there. Transform, transform, divergent, transform. So this plate is moving that way. This is the same plate. It's moving that way, and it's subducting, and that's what's causing the chain of the Cascadian volcanoes. So I hope you play around with Google Earth a bit. For sure, check out your house. Check out all the places that you've been recently in Google Earth and just see what it looks like because it's fun and it's geography. And that's pretty much it for this. I hope you enjoy Google Earth. It's, I think, one of the most amazing, hours of entertainment. One of the most amazing programs ever. That's it. Good luck with Google Earth.